Hi everyone. In this video, I want to talk about one of the fundamental data structures called a linked list. We will learn what it is, how it functions, and why it's so useful. So let's get started. Now, there are two ways we can maintain a list in memory. We have arrays and linked lists. Both of them come with advantages and disadvantages. But before we talk about where linked lists come in handy and why they're important, let's actually learn what they are and how they function. Imagine a series of interconnected nodes where each node holds a piece of data and a reference to the next node in the sequence. This, my friends, is the essence of a linked list. Unlike arrays, which store elements contiguously in memory, a linked list stores its elements in separate nodes, and the connection between these nodes are achieved through pointers or references. So let's say we want to save 5 different values to a linked list. How do we do this? Well, as I mentioned previous, we have what we call nodes. Every node holds data and the address to the next node. So we can see that the first node holds the data, 15, and reference to the next node. Now, what these numbers are, you can think of them as memory addresses, right? Where they are stored in the memory. Now, these numbers aren't actually valid memory addresses, but for this example, I just picked out some like random number, and you can think of them as actual memory addresses. So the first node is going to hold the first piece of information and the memory address of where the next node is. Then the next node will hold the second piece of information together with the address of the third node, and so on until we have reached our last bit of information that we want to save. Now here the address is null because there is no next node. We have reached the end of our linked list. Therefore, the address is equal to null. And that is basically how it works. We can see that every node is linked with each other, therefore the linked list. Now that we know how linked lists work, let's actually talk about the disadvantages of arrays. Let us say we want to insert a new element in the middle of the array. We have an array of 10 elements and we want to insert a new value in index 4, for example. We first need to shift all the values to make room for the new value. Now that it's empty in index 4, we can finally insert the new value and we are done. This doesn't sound like too much of a problem, but let's say we have an array of size of 1 million, for example. Suddenly we need to shift a lot of elements, and it can take a while. We encounter the same problem if we want to delete. Once deleting a value at a specific index, we need to shift everything to the left. So this means that arrays aren't very efficient when inserting and deleting elements. Let's see how a linked list works when adding an element. When you insert a new element, a new node is created, and its reference is appropriately updated to maintain the logical order of the list. So let's say this new node we want to save at the position 2. All we need to do is update the first node's address to point to this new node. And this new node's we point to the now third node. And this is how it works. This process is efficient as it only involves updating a few references rather than moving multiple elements. Now, let's say we want to delete a node from our linked list. That is similarly straightforward. The reference of the previous node is updated to point to the next node, effectively bypassing the node to be removed. Once again, this operation is efficient, requiring only a few reference updates. Now, it is advised when this node address gets updated to point to this node, it is advised to actually delete this node because Even if this is no longer part of the linked list, it will still stay in memory, and it is advised to delete it from memory so that we can free up space for other programs who maybe need it. But you can see that this node is no longer part of the linked list because there is nothing that is connecting to it. Now, there are different types of linked lists. Let's start with the simplest type, the singly linked list. In a singly linked list, each node contains a data element and a reference to the next node. This structure allows traversal only in one direction, from the head to the tail. Now, imagine a linked list that takes things up a notch, the doubly linked list. Each node has an additional reference to the previous node in a doubly linked list. This bidirectional connection enables traversal in both directions, offering more flexibility, but at the cost of increased memory usage. Lastly, we have the circular linked list. In a circular linked list, the last node's reference points back to the first node, creating a closed loop. There are two types of circular linked list. There is either circular singly linked list and circular doubly linked list. In a circular singly linked list, we form a closed loop that can only reach from the head to the tail. But in a circular doubly linked list, we form a closed loop from head to tail and from tail to head. Because remember, in a doubly linked list, we have access to the previous node, but we don't have that in the singly linked list. So that is the difference between the circular linked lists. Now, to summarize, linked lists provide dynamic memory allocation, efficient insertion and deletion, and a flexible size, which overcomes the limitations of arrays. However, they also introduce some trade-offs, such as increased memory usage for doubly linked lists and a potential complications with traversal in circular linked lists. And that's a wrap on our exploration of linked lists. They're an essential tool for every programmer, offering versatility and efficiency in managing data. However, it's important to choose the right data structure based on the specific requirements of your program. Thank you for joining me today. If you learned something new, make sure to subscribe, like, share, and all the other amazing stuff. If you wish to learn something new, make sure to leave it down in the comments and I will be sure to make a video on it. Be sure to check out some other tutorials while you're here, and thank you so much and see you next time.